Hello, Brad. Today I'm presenting some thoughts about deep learning and convolutional neural networks in image classification. I separated this presentation in very basic talks about every single aspect I think is essential to understand the principles of deep learning and how they can be applied. So I will talk about deep learning and CNNs. I'll be presenting some examples of codes because I think it sometimes feels too abstract, say deep learning or machine learning, and so on and so forth. How the most basic of CNNs works with architecture, convolutional layers, pooling layers, if connected layers. Those layers will be more like a simple way to go about it. Those are not the only layers you can have in a deep learning algorithm. And then I'll be presenting some application like detection. When I say image classification, I think it's something more like on the way of how you can interpret some image in a way you want to interpret, not just classify it. So, what is deep learning? You can say thinking something like a subset of machine learning. When you have multiple layers, they are structured, thinking in a way we think, in how a human brain will process, learn to recognize patterns, features in large data sets. And why I talk about specifically CNNs. CNNs are the most simple way to think when you design a deep learning model, and they are the basic structure. Because CNNs are highly effective, identifying visual pictures from edges, textures, patterns, whether it's image classification or an object detection. This is a simple model in machine learning. We have three functions, but they are the same layer. This is a machine learning algorithm. It's not something super complex. It's when you have dense fully connected layers, they are made to identify patterns and make a decision whether what you try to train it to identify is working or not. So that is a simple machine learning algorithm. And then you have a CNN. On CNN, we have multiple layers. Mainly three layers, because when you have a convolutional, you have the function, a com2d. A com2d have specific ways to describe it. In a CNN, you can think like we have a feature map. With that feature map, we can now think in terms of small windows that they are called kernels. Kernels are this first number. The second number is the size of the kernel, the window. The window, you can think like you have a window. Like that, you have a tree. That means you have a 3 by 3 window that we can then apply in each part of this feature map. And then the activated function will be like how it goes across the feature map to identify a feature, or like something like in the lines of you have an image here. This kernel will be mainly focused on identifying borders, contours, shapes of things. Then we have a max pooling 2D. The max pooling more is for computational. First, we think in more of a sense of you have a 2D map in the feature map, and then you can flatten that, flatten in a sense, and make a 1D function. Then you will have less computational cost. Then you have multiple layers, como 2D, max pooling. Every time you do a convolution layer, you usually do a max pooling so we can determine pixel values and then make it simple to the dense layer, identify that and connect all the dots. How I say, the basic architecture of a convolutional network, mainly three layers, a convolution layer, a pooling layer, and a fully connected dense layer. Each layer will have its own role in the process of recognition image or processing how tasks were made. This is the basic structure. Like I said, the convolution layer will be always the core of the CNN. It is responsible for detecting those features such as edges, shapes, patterns, and is done by sliding these kernels, these filters, across the image that is made of the feature map. Like I said, it can be whatever size of the site. It can be whatever dimension of the size, because in the previous example, I had a neural network to identify RGB image. So you have three feature mappers, not in the sense of a 3D image, it's more of the every feature image you have will be the whole set of 0 to 256 bits. So for each position, if you will perform a product, that product is not just a simple calculation, it's a tensor. That tensor has its own ways of producing values, and how it produces depends on the activation model. Each activation model has its own purpose of what's going to give as an output. Like I said, the output will be a feature map that highlights all the specific pattern and features in the input image. A pooling layer will always be used to reduce the spatial size and decrease the number of parameters and the computational cost in the network. Like I said, same thing, it will be a small window, will be the size of the site, doesn't need to be the same size of the CNN, and it's not only the max pooling and the average pooling, it's like a probability function. The fully connected layer will be used to extract and will connect all the dots between the layers and will make a decision based in the features it can detect and describe. In this way, will be always dependent on how this layer can give output. When I say shapes, contours, that depends on the hardware you're using to give data to the network. Because in a self-driving car, most of the data is from lidars, not so much image. Images are more a spatial definition for the car. Most of the data that makes decisions are based on the density maps of the objects around the car. So it's not just a simple taking of an image. You can have another ways of data being fueling neural network. This image, I think, is a good way to represent how you don't know what's happening between the layers. Because you have an input image, you have its own parameters, features, so on, and you have a convolution layer. This way you can always understand that when you start the neural network, you have a small windows, few kernels. As you go on the neural network, you will always be increasing by multiples. So if you start like in 8 kernels window 3 by 3, the next one will be 16 kernels, and 32 and so forth, 64. And then after you did all the mathematical layers, between layers, so forth, when you have the density layer, you connect every dot between the feature map and the decision process. Then you don't know what is happening between all of the convolutional steps. So that's why you can say it's deep learning, because you have a supervised algorithm that you really don't know what's happening inside of it. Like I said, just not a matter of classification of image. You can identify specific features in the image. You can classify, you can detect, and you can segmentation, make a segmentation map where you really do the outlines of the image you're trying to classify. That's it for today.